In today's video, we will derive the Euler's equation of motion and the Bernoulli's equation of motion. What is Euler's equation of motion? It is the equation of motion in which force due to gravity and pressure are taken into account. Now here let's just consider a streamline in which flow is taking place in the S direction as I have shown in the figure. This is a cylindrical element having length ds and the cross section is dA. The cross section is dA and the length is ds. And the forces that are acting on the cylindrical element that are, we'll just see in the diagram. Firstly, pressure is equal to force upon area. So we'll have force is equal to pressure into area. And here in this direction, the pressure force will be acting in the direction of the flow, which will be P into dA, because force is equal to pressure into area, and here the cross section area is dA. So P into dA will act in the direction of flow. Then the second one that will be acting is in this direction, which is in the direction opposite to the direction of flow. Here it will be P plus the variation of the pressure with respect to the length we'll have to consider. So it will be del P by del S into ds into dA. We'll just write here that our second force is P plus del P by del S into ds into dA, which acts in opposite direction of the flow. Del P by del S is the variation of pressure with respect to length. Then weight will be acting. Now weight will be acting at an angle of theta, and weight is equal to rho Vg, V, which is the volume, which will be equal to area into length, that is dA into ds. So we get our third force, which is weight of the element, which is equal to rho g dA ds. Then we'll find the resultant force on the fluid element in the S direction, and that will be equal to mass of the fluid element into acceleration in the S direction. Now acceleration will denote it using as, and mass will be rho dA ds. So it will be rho dA ds into as. How we got this mass equal to rho dA ds? Let's just see that. Mass is equal to density into volume, because we know that density is equal to mass upon volume. So mass will be equal to rho into volume, which is volume is dA into ds. We have already wrote the forces acting on the fluid element. Now we'll write the resultant force, which will be PdA, because it is acting in the direction of flow. P plus del P by del S ds into dA is acting in the opposite direction. So it will be minus P plus del P by del S ds into dA. Weight is acting in the downward direction and it is acting at an angle of theta. So it will be W cos theta. We'll write it as rho g dA ds cos theta. And this will be equal to mass of fluid element into acceleration in the S direction, which will be equal to rho dA ds into as. Then we have the acceleration, which is equal to change in velocity with respect to time, which is dv by dt, and velocity is equal to distance upon time, which is ds upon dt, is equal to v. Now we'll write as in terms of v, s and t, which will be del v by del s into ds by dt plus del v by del t. We have taken the partial differentiation. Now as will be equal to del v by del s into this ds by dt is equal to v. So we'll write it as v into del v by del s plus del v by del t. Here the flow is steady, and for steady flow del v by del t will be equal to 0. So we'll write as equal to v into del v by del s, because we have del v by del t equal to 0. Now we'll just place this in this equation. Firstly, we'll expand this bracket. PdA minus del p by del s ds into dA minus rho g dA ds cos theta, which will be equal to rho dA ds into as. As is v del v by del s. Now we'll just divide this rho dA ds on the left side. PdA minus PdA will be equal to 0, and we'll have minus del p by del s ds dA divided by rho dA ds minus rho g dA ds cos theta divided by rho dA ds, which will be equal to v into del v by del s. Now this dA ds will get cancelled, and here rho dA ds will get cancelled. So we'll be left with minus 1 upon rho del p by del s minus g cos theta is equal to v into del v by del s. We'll take all the terms on the right hand side, so it will become positive. So we'll be having 1 upon rho del p by del s plus g cos theta plus v into del v by del s equal to 0. Then here this angle theta is formed in the diagram. Let's just create that diagram. The angle is theta, and here we have ds, and this is say dz. Then we can write cos theta equal to adjacent upon hypotenuse, which is dz upon ds. We'll just substitute this here in this equation. So it will be 1 upon rho del p by del s plus g into cos theta, which is dz by ds plus v del v by del s equal to 0. In all the terms we are having del s, so we can just multiply it with 0 and it will become 0. So we'll be left with del p by rho plus g dz plus v dv equal to 0. And this equation is the Euler's equation of motion. Now let's just derive the Bernoulli's equation. The Bernoulli's equation will derive from the Euler's equation, but here we'll make some assumptions. And these assumptions are: flow is steady, incompressible, and irrotational. Also, the fluid is ideal, and by ideal fluid we mean that the viscosity will be 0. These are the assumptions, and these are asked in the competitive examinations, so it's very much necessary for you to remember these assumptions. We'll derive the Bernoulli's equation by integrating the Euler's equation of motion, which is del p by rho plus g dz plus v dv is equal to 0. We'll just integrate this, and on integrating we have integration of dp by rho plus integration of g dz plus integration of v dv, which will be equal to a constant. As this flow is incompressible, so the density will remain constant. So here integration of dp by rho will be p divided by rho, because rho is constant, plus g dz. So integration of g dz will be g into z, because g is a constant, and integration of v dv will be equal to v square by 2, and this will be equal to constant. Now we'll just divide this by g, So we have P upon rho g plus gz upon g. So gg will get cancelled. So we have z, and v square by 2g is equal to constant. We got this equation, which is the Bernoulli's equation. P by rho g plus v square by 2g plus z is equal to constant. And it's very much important to remember this equation. The first term, which is P by rho g, that is known as the pressure head or pressure energy per unit weight. It can be asked in MCQs that what do we call the first term. Then the second term, which is Z, that is the potential head or potential energy per unit weight. And the third term, which is v square by 2g, that we call it as the kinetic energy per unit weight, or we can call it as the kinetic head. It can also be asked what is the unit of all the terms. Then the unit is meter. This way you can derive the Euler's equation of motion and the Bernoulli's equation. Thank you.